Annual Borlaug Memorial Lecture. This lecture is intended to commemorate Dr. Borlaug's fight against world hunger and to celebrate those who follow in his footsteps. This lecture is made possible through collaborations with the World Food Prize and the Departments of Agronomy, Plant Genetics, Plant Pathology, and Forestry, as well as CFANS, the college. Working hard behind the scenes, the organizing efforts of this lecture were led by Mary Buschetti, Robert Stupar, and 3 students from 3 departments that Norman Borlaug was an alumni of. So allow us to introduce ourselves as your hosts tonight and as the student organizers. My name is Alina, and I'm a master's student in applied plant sciences.
My name is Alicia. I'm a master's student in the Department of Plant Pathology.
And my name is Polly. I'm also a master's student in the Department of Forest Resources. And we would now like to welcome Dean Brian Burr to the stage to give us the opening remarks for today's special memorial lecture.
Well, thank you all. Thank you to the students for hosting this and preparing. It's always a pleasure to be here this time of year. We recognize Dr. Borlaug with the World Food Prize. So thanks for inviting me to give it a little introduction. It's great to see everyone here. And I always have, as I was walking up here, can't have walked by Dr. Borlaug's statue. And just for context, I always joke he grew up 40 years before me, 40 miles north of me, and 40 times smarter than me. Which is our only relationship, although I've met him a couple times, but of course he grew up in Iowa and I'm just south of there, or was just south of there once upon a time. So farm there, near there, just directly south of him. But it is a delightful, I want to thank Dr. Govindaraj. I rehearsed that for hours now. Dr. Govindaraj for joining us today from India. We really appreciate you joining us, and congratulations on your award. For field research as a senior crop scientist at the Harvest Plus. So thank you for joining us. We're delighted to host you here at the University of Minnesota and in Minnesota. I learned earlier I had never in my lifetime seen millet growing anywhere, so I was glad to hear that it's growing in Nebraska and Kansas, not yet in Iowa, because this last year, of course, in Minnesota, we had some dry conditions as well. And thankfully, some of the importance of the work that's done here is, of course, that ability to develop new crops with drought tolerance and drought resistance and characteristics. So I can speak from our perspective, we're only about 20% lower on yields, which was looking pretty iffy for a while. But the work that you're doing to advance both, which is a key part of our goals, advancing nutrition through improved varieties, as well as advancing the yield of those, is tremendously impactful for our work. So thank you for joining us again. And then also I'm delighted to introduce Dr. I'm not introducing this for just as just my way of it. There's a more formal introduction coming up. But Dr. Thompson, who's joining us from Michigan State University, who is also, you'll find I bring my Iowa connections up again to that age where you start to bring up the past a lot, has her bachelor's degree from Iowa State University, and from the University of Minnesota received her PhD here. So really good, another pedigree that goes back to that Iowa-Minnesota connection that's just terrific to see. So Eddie, she's being recognized as an emerging leader in Plant Science Award. So congratulations on that. And thanks for joining us today as well from Michigan State, who had a rougher Saturday than Minnesota did. I'll say that. If you didn't watch that, I didn't watch it, but I did see the scores of Michigan State game. And so with that, I also do want to, out of deep respect, of course, that just this last couple months, and many of you certainly will know this in agronomy, we lost 2 giants in the field. Dr. Swaminathan passed away in September, I believe. And Dr. Phillips, of course, as a faculty member here, the Regents Professor, passed away. And so it's always, as we recognize Dr. Borlaug and that heritage and lineage, that the University of Minnesota has been at that intersection for decades and generations of students and others coming around. And so as students are hosting this today, it's that reminder that people from very, very different backgrounds, very humble beginnings, as we see here today, can have a tremendous impact on this goal that we all share of feeding the world and doing that sustainably and providing nutrition to people. So it's particularly meaningful to have the connections here today that we'll be hearing from our speakers, and excited to do that. And just a reminder, this is just reflecting on the work that I do, which is in economics. And the simple issue that I was looking back, there's the Global Health Index that some of you are probably very familiar with. IFPRI, back when I knew it more, IFPRI was doing it. Now it's been taken on by a couple of NGOs internationally. But it's stark that we have improved over time, of course, in global hunger index. If you look at the last 10 to 15 years, we've been largely stagnant in advancing the cause of improving and reducing hunger across the globe. And part of that is that we often forget about it. We'll talk a lot today about the improvements that have been made in millet, for example, and pearl millet in particular, advances in corn, other cropping systems and horticultural systems. And yet we have these challenges, which we're obviously keenly aware of now, of some of the policies and practices, governance conflict that occurs in hunger, but also just the fact that how are we going to produce still today and feed a growing world? And right now that people usually, especially here in this part of the world, we talk about our yields are increasing, but yields aren't the total story ever. For economists, we look at total factor productivity, and total factor productivity becomes climate, it becomes the weather, it becomes the rainfall precipitation, it becomes soil characteristics and soil health. And usually we just look at acreage and how many acres in production and what the yields are. But that's changing over time. And in fact, globally now, we're declining at about 0.1 to 0.2%, which doesn't sound like a lot, but over 5 years, you got a 1%, over 10 years, you got a 1% change. Over 5 to 10 years, you've got 2 to 3% declines. And population is still growing at about 1.1%. It's tapering off, but it's still there. So this goals of what we're talking about here today are to achieve that goal of feeding that growing population, doing it sustainably, and use dramatically less resources with the resources hitting those. So with that, I appreciate the opportunity to introduce and welcome you today, welcome all of you and our speakers, and we'll look forward to hearing from them. So thank you all for joining today.
Thank you, Dean, for that wonderful introduction. To transition into our next portion here, I'd like to ask you a question. Did you know that in the state of Minnesota, October 16th is recognized officially as Dr. Norman E. Borlaug World Food Prize Day? We have here with us today Assistant Commissioner of the Minnesota Department of Agriculture, Patrice Bailey, who will read the proclamation that declares this as a statewide holiday each year. Please welcome Patrice Bailey.
Well, thank you so much. It's great to see a fellow cyclone here, as well as both of you guys in the honor. It is, interesting enough, CFANS was my first time when I moved to Minnesota, so had a lot of love and allegiance here. But yes, I am very thankful because I did this last year. I'm really thankful to be here, to be able to read the proclamation. I had to put my glasses on because the words are very, very small. Okay, here we go. Dr. Norman Borlaug was born March 25th, 1914 on a farm in Iowa. He received a bachelor's degree in forestry from the University of Minnesota in 1937, and then started work with the U.S. Forestry Service at stations located in Massachusetts and Idaho. He returned to Minnesota and received a master's degree in 1941 and a doctorate in 1942, both in plant pathology from the University of Minnesota. And Dr. Borlaug was a varsity wrestler at the University of Minnesota and helped introduce the sport to high schools throughout Minnesota. As an exhibition matches, as well as refereeing in Minnesota State High School wrestling tournaments. For his lifelong advocacy for the sport, he was inducted into the National Minnesota University of Minnesota, Iowa and Iowa High School Wrestling Halls of Fame. And in 1944, Dr. Borlaug accepted an appointment as a geneticist and plant pathologist to organize and direct the cooperative wheat research and production program in Mexico, where he was immersed in scientific research in genetics for the next 16 years. He was extremely successful in finding a high yielding, short-strawed, disease-resistant wheat. And Dr. Borlaug, agriculture research in Mexico, improved crop management and practices, and transferred agricultural production during the 1940s through the 1960s, and implemented throughout the North America, Asia, and Latin America. And in 1970, during the middle of his career, Dr. Borlaug was awarded the Nobel Peace Prize for his work in agriculture, which resulted in saving hundreds of millions of human lives by preventing famine and alleviating hunger and malnutrition. His work and that of colleagues was responsible for saving hundreds of millions more in the second half of his career. When able to persuade the Nobel Committee to develop a prize specifically for agriculture, Dr. Borlaug founded and developed the World Food Prize Foundation to annually award a prestigious prize to extraordinary efforts in food security. And Dr. Borlaug was recognized with the nation's highest science and civilian honors, the National Medal of Science, Congressional Gold Medal, and the National Academy of Sciences Public Welfare Medal. He is the only person in history to have earned these awards, along with the Nobel Peace Prize and the Presidential Medal of Freedom. And Dr. Borlaug dedicated his life serving humanity until his death at the age of 95. His legacy will live on as an inspiration to young people, a reminder of the importance of agriculture production, and a model for the significance food plays in ensuring world peace. So, therefore, I, Patrice Bailey, in place of Governor Tim Walz, on October 23rd, proclaimed that this day would be Dr. Norman E. Borlaug World Food Prize Day. Thank you very much.
Thank you again for reading that. Thank you for reading this proclamation highlighting Dr. Borlaug's journey and aspiring achievements. As part of this lecture, we want to celebrate up and coming leaders in plant sciences. The Emerging Leader in Plant Sciences Award seeks to recognize an emerging leader in the plant sciences with characteristics and values that reflect Dr. Norman Borlaug's legacy. The awardee is a University of Minnesota alum with a record of impactful and innovative research in the plant sciences or related fields, and they must have obtained their terminal degree from the U of M or elsewhere within the past 15 years. The awardee also displays a strong commitment to social impact and leadership within their respective research communities and beyond. This year's award goes to Dr. Addie Thompson, and I would like to turn your attention to Dr. Michael Kantar on Zoom, who has nominated the recipient and will be sharing a brief introduction.
Hello, everyone. I'm sorry I can't be there in person, but it's my absolute pleasure to introduce Dr. Addie Thompson. As Dean Burr said, she completed her bachelor's degree at Iowa State before coming to Minnesota, where she did her graduate work in Dr. Gary Muehlbauer's lab. Then she did a brief postdoc with Dr. Rex Bernardo before doing another postdoc at Purdue University. And then she took her current position as a professor at Michigan State University. Addie is she's really truly a leader in the plant sciences. She's a prolific researcher, having published dozens of papers despite her her youth in the field. She's an excellent grant writer, generating millions of dollars in research funds. And she's a wonderful teacher, getting just fantastic reviews from all of her students. She's really innovative in the work that she does in phenomics and genomics and how we use computing in agriculture. And, more than that, she's really a fantastic mentor. She fosters a lab community where everyone in her lab feels valued and where students and all lab members are really able to reach their full potential. Dr. Thompson truly represents, not only the best of the University of Minnesota, but of, everyone in the professorial ranks. So without further ado, Dr. Thompson.
Wow, thanks, Mikey. One of the themes that you're going to hear in my talk, so I get about 15 minutes to talk, just so you know. One of the themes that you're going to hear is that making connections for you grad students in the room, making connections now is really important. And Mikey's a great example of that, because everything that he just said about me, I would have said about him when we were in grad school together 10 years ago. Okay, well, first of all, thank you, everyone. Thank you to the committee. Thank you to Mikey for the nomination. And thank you to the wonderful hosts and hostesses that have been with me the last day or so. This has been an incredible experience. I'm honored and humbled to be here. The past that you, how do I make this go? No, that's not cool. Okay, yeah, works for whatever reason. So the background that you just heard about is here, right? You heard about Iowa State, Minnesota, Purdue, yes. The pieces that you didn't hear about was that during my time here at the University of Minnesota, I had one kid, and then during my postdoc, I had a second. And so this is at Minnesota. These are both at Purdue in a sort of field, and this is kind of present day. So family's always been important to me, and I've been really lucky to have mentors that shared that perspective. That's been hugely important. The other thing that's not really a publicized part of my background is that I am the product of a lot of youth programs. And so I did not grow up in a farm. I didn't grow up in I guess you could say it was kind of a farming community, but I grew up in town, a block from Main Street, which is a very small town. My parents were both teachers, and they knew the importance of education. And at the time, the state of Iowa did too. And there were a number of donors and funders that funded programs, one of which the Bell and Blank Center. So this actually is at the University of Iowa. Normally, Iowa Staters join you in your hatred of University of Iowa, but this is one case where actually they were doing something good, something right. Yeah. And so back throughout my junior high, middle school, high school days, I would spend multiple weeks in the summer at research camps, doing science on campus with professors, living in the dorms, funded because I wouldn't have afforded to do it otherwise. But that's what got me really excited about science, and particularly in genetics. And then the follow-on to that was I had the opportunity to participate in the World Food Prize Youth Institute. So you've already heard that Borlaug was really instrumental in creating, actually, did we say that? Borlaug was really instrumental though in creating youth programs, because that was one of his big focuses, was on educating the next generation of plant scientists. And that's what got me interested in agriculture and international agriculture, plant sciences. And I actually had the opportunity, I went to the Philippines for 8 weeks back 20 years ago and did research over the summer. And then there's a number of other programs listed here as well. But I definitely wouldn't be here today if it wasn't for that. One tidbit I'll share, I did have the chance to meet Norman Borlaug a number of times, the first of which was in the interview for the internship. I was 16 or 17 years old, and he asked me a question in Spanish. And I think I responded something that made sense, but I think he was kind of sussing out whether which research station they were going to put me at, right? And I ended up at Erie, so clearly my Spanish wasn't good enough to be at Senate. But I did have the chance at one of the Tri-Society meetings to actually go and thank him and say, like, you inspired me, and I'm on this trajectory because of this experience. And it was really cool. As was usually, there was a whole room full of important, impressive people, and he didn't want to talk to any of them. He only wanted to talk to the grad students and the undergrads that were in the room. So now I am at Michigan State University. One of the main goals of my lab is improving plant breeding. So we do plant breeding research. My main focus is maize, although I do work in sorghum a little bit as well. And I want to take a brief minute to point out how I got here. The position at Michigan State when it was advertised was listed as computational maize genetics / genomics. And I wasn't sure that I fit even 2 of those adjectives, let alone all of them. But a friend and colleague of mine said, no, you really should apply. I think you'd be great. And who knows what they're really looking for. Search committees put these things together, but then you get your chance to go and actually pitch your case and share your vision. And if that doesn't align with their vision, that's fine, but that's what it's for. And it was advice like that that really helped me a lot throughout my career, especially if, like me, any of you struggle from imposter syndrome and you're not sure whether actually you're a good fit for something or whether you're the right expert for something. Give it a shot. But having people that help lift you up and then reciprocating in that regard, it's been important. Okay, so back to my lab. We study the genetic architecture of various quantitative traits and work toward improving approaches for prediction that utilize genetics and genomics, but also phenomics, genotype by environment by management interactions, simulating breeding programs, and optimizing strategies. So we do a lot of germplasm characterization, what you might call trait discovery, as well as germplasm and population development, so pre-breeding. So we partner with a lot of industry groups actually to kind of move that into varieties. I do not release any varieties myself. This is what it looks like. So we do have a pretty extensive field and phenomics operation. Someone asked me the other day how many acres. I hadn't counted before, but I did. It's around 18 acres per year. So that's kind of the scale of what I do up there. There's a lot of other maize researchers up in Michigan State, so I've had the opportunity to expand and do what I want. It's been a big challenge, but a big opportunity and very exciting. So current projects. One of the projects in the lab right now focuses on nitrogen response. So nitrogen is a really expensive input for maize, and different varieties respond differently. So that's one of our current interests with Brandon Webster, who's a PhD student there. I have a postdoc right now working on sorghum functional genomics, and she calls it ecophysiological traits, but it's a combination of sort of plant morphology, biomass, and photosynthesis traits. And then another one of my big projects focuses on tar spot disease resistance in maize. And then as kind of a side project of that, we've been working with phenolic compound accumulation across species. So that's kind of a group in the lab that works on that. We also are the Genomes to Fields location for the state of Michigan. I'll talk a little bit about this in a minute, but you have this trial at your site as well. And then I have a student that works on breeding program simulation and miscellaneous other projects. I don't have time to talk about much of any of these today. It's not really a lot of a scientific talk, but I'd be happy to talk with you some other time or answer questions. Okay, I do want to mention tar spot a little bit because I know that you guys started getting it here as of 2019. So that's pretty exciting. It's a hot topic. It is a pathogen that is a fungal pathogen, an Ascomycete fungi caused by the pathogen Phylochoromatus. Spread by wind and water, causes these shiny black spots. And the rule is that if you can't scratch them off, then it's probably tar spot. If you can, it's probably insect frass or dirt or something else. But it's been around in Central and South America for over 100 years, came to the US in around 2015. So it can cause these varying spot sizes with or without the necrotic lesions around it, covers the leaves, reduces photosynthetic capacity, but it quickly breaks down the canopy, which results in lodging. So that can lead to up to a 40% yield loss because it pulls nutrients from the stalk. So the projects that I have in this space have been a collaboration with Dr. Marty Childress, who is a pathologist. I am not, I'm a geneticist. So he knows all the things about the disease, and then I work with the resistance side of things. We have a couple of grants that have been funded through this project, and it's a collaboration amongst multiple institutions. But so far, we have been screening diverse germplasm, and we were able to find some resistance. I put tolerant in parentheses because I don't want to commit to saying that they're fully resistant yet. But we have mapped genetic loci contributing to that and started some pre-breeding where we're back crossing that into resistant lines. We've done some validation work in an external population, and then started developing and testing some new populations. The fun thing, though, is that I've also been using this project and these populations as sort of a test bed for some of the phenomics technologies that we're developing. And for tar spot, that means improving detection and prediction for management decisions. But for other projects, it would have different implications. So this, if you're not familiar with orthomosaics, this is sort of a multi-picture image of the tar spot field that I've just on inset with this a spectral reflectance vegetative index. But some of the things that we're hoping to address in the lab are part of what we focus on is on predicting how varieties are going to perform. And that's important from a plant breeding genetics perspective because we want to assess a variety's usefulness. The best way to do this would be to grow lots of locations, lots of trials, many reps. But because that's an expensive operation, we have to take some shortcuts, right? We can use genetics to do that. So genomic prediction is pretty well established, but it doesn't always perform that well into new environments. Crop growth modeling is another approach that can be used using physiological information. You can simulate the environments, the varieties in different environments, but it relies on a lot of tedious hand-measured phenotypes to actually input into the model. And so one of our questions is, could we predict some of those sort of parameter phenotypes some other way? And where this led me to thinking about, actually in retrospect, was just the whole concept of addressing bottlenecks. So you're faced with a problem. And this is a little bit geared more toward grad students in the room, but I think it's useful perspective for others as well. Usually the problem can be broken down into either people and skills or equipment and tools. If it's people, does somebody have the expertise? If so, you should collaborate with them. If not, somebody has to learn it, right? Train and study. If you're not sure, you got to ask. That's an important skill set. I realize this seems silly, but it's actually critical to think about. So if the problem is equipment and tools, does that tool exist? If so, if you can, buy it. If not, you can build it. If you're not sure, then test. If you're not able to build things, that's when you have to collaborate with an engineer that they can build for you. But the part that I really want to emphasize here is that there's a lot of skills here. So you probably thought coming into your PhD that you're going to acquire some critical thinking, you're going to learn new knowledge and skills, you'll train and study and gain this expertise that you need, right? But over here, we have communication and confidence. You have to have the guts to go ask somebody who's an expert in their field if they can help you with this project or to collaborate with you on something and convince them that it's a cool idea. If you want to build and test something, you need a lot of creativity. And it's these soft skills that I think are really important in your training as you go through your career, that those are the things you need to pick up on. And then always there's time and cost, right? Maybe you could buy the tool, but it's really expensive. So you have a workaround. Just as I said, I would bring up genomes to fields again. This is a map showing all the different locations as of 2019, at least when we were starting this project. And so we were interested in using this as kind of a test bed. And we had painstakingly measured thousands of plants and we were getting great data. But the problem was that it was incredibly slow. It takes a lot of time and effort and patience to measure a lot of plants to get the kind of data we needed. So our thought was, can we get this data some other way? And it turns out this problem required a lot, all of these different approaches. So the first thing I did was ask around. Does anyone have expertise in this area? It turns out at Michigan State, there were people who had expertise in different parts of the pipeline, but there weren't a lot of plant phenomics focused people yet. I formed a lot of collaborations. I cold emailed a lot of people. I found people that were interested in the problem but hadn't started working on it yet and put together a group. We wrote some internal grants to acquire some of the tools that we needed to actually get the data that we wanted. We started testing those out. We started building pipelines and training people how to actually use the equipment and then use the data. And this, again, required a lot of communication and confidence. And I'll go back to the idea of kind of mentors in my life that have benefited me in some way. We were first talking about, when we were putting together the grant, we were talking about, okay, who's going to lead this? And I thought, well, it needs to be somebody who's more senior. I'd been at Michigan State for 1 year and I was a new assistant professor. Who in their right mind is going to fund me, right? And I said, well, it needs to be somebody who has some experience in plant genomics and would be convincing about why this is an important area. And it was Shinhan Shu who looked at me and he said, well, it has to be you. Who else is it going to be? And so I'm looking around the room. And it occurred to me, oh, I am the expert in the room. And that was a new experience for me, even though it seems like it should have been obvious. But having people that had the ability to lift me up and say, like, yes, you're the right person for this job, really helped me out a lot. So we did get the grant and we put together a team of plant scientists along with computer scientists and engineers. And it made for a great starting point for launching into this field. The ideas I came into the project with were that if we could use sensor technologies to measure kind of component traits, then we could use those to kind of combine into what I call these more like composite traits. Because if you're using genetics to predict yield, you might be working against yourself in subsequent seasons. Some years your yield is limited by something different than what it's going to be limited by the next year. But if you're using genetics to predict things that are more heritable, then perhaps you can combine those into those traits of interest. But we didn't know how true some of these red dots were. Like, could you really use LiDAR data to look at tillering propensity in sorghum, for example? We didn't know. So that was one of the things we wanted to test. This was actually data from my postdoc. The blue dots are measured leaf area along development. So we actually marked leaves and measured leaves subsequently. And the red line is a power function that was fitted to it. I've never gotten data this nice. But turns out you can model this power function. Leaf area is really, really accurate. So this just takes 3 parameters to parameterize this function. So our question was, if we have this great predictive values, can we actually get those some other way? So we tried using LiDAR data. This was back in 2020. So you can see there's 7 dates here of LiDAR data. We actually ended up using like a voxel model, which I can, again, I'll talk about some other time. But it did a really good job. So we compared our LiDAR data predictions to using genomic prediction with a couple of different methods. And in a lot of cases, we were as good. Some cases we were not, but a lot of cases we were a lot better. So that was pretty exciting. We've applied this also to a project where we're looking at the genetics of nitrogen response. The question being, if you were a farmer and you wanted to guess an optimal amount of nitrogen to use, would there be a way that you could guess that at the beginning of the season using like marker data, for example? This is a case where we're not sure if the project's going to work, but we've set it up in such a way that we'll learn a lot of really cool science either way. So this happens to be the field as it is currently as of last month. So this is from September, and you can kind of start to see visually the designation between kind of our high and low nitrogen varieties and between the hybrids and the inbreds. So we're excited about using that data to make some predictions and analysis, following up on previous work. The other thing I'll touch on, as I'm probably running out of time here, is I do teach a plant breeding class, but one of the other courses I teach is in computational and plant sciences. And we've set it up as a kind of a partnership between industry and academia, but the students work together across departments and they do project-based research. So this is an example from last year, I think, but it's an example of one of the groups where they were looking at images of sweet corn ears and calculating the amount of blank fill on the ear. So learning how to segment imagery and segmenting using a threshold that catches kernels when it catches ears and then basically subtracting the two. So this was a partnership with Syngenta. And I will say that was a partnership that came out of my time in graduate school. So the current sweet corn breeder there was a Minnesota alum as well. Another example, we actually drove a robot through the beaver crop for the field trials in Ohio. So this is LiDAR data from their trials. And then this was working with the potato breeder on campus. We were pulling out hyperspectral imagery from a drone and looking at diseased versus not diseased plant canopies. But the reason I bring up these 2 examples is because of where the students started from and where they ended. So this is kind of some of the outputs of where they ended up, but where they started looked like this. So the students earlier in the semester came to me and said, this is what the data looks like. You can't see the corn. What's going on? And it was because when the LiDAR was spinning lasers, when those lasers go out and hit an infinite value, like the sky, they report back with some extreme infinite value. And that was getting plotted up here. So once they filtered all that out, this is actually what the point is. Similarly, for the hyperspectral project, they showed me this plot with different varieties having disease or not disease. And I said, this is a huge problem. I've looked at enough hyperspectral traces to know this is not a plant. This is soil. You're picking up on something that's not even vegetation. And I was particularly disturbed because I had made the shapefiles. I had pulled out that data. So I knew it wasn't their fault that they didn't have plants in their data set. But through that, we discovered that our visual and our spectral imagery was shifted diagonally by about 1 meter. And so that's where we learned it. But once we just shifted the shapefile over and corrected that and extracted the right data, then we could see it. But I think these were really, really valuable experiences for that class because the students got to see what it looks like when there's a problem with a data set. And that's going to be most of your data sets. There's going to be some problem, right? So learning how to deal with problems and how to troubleshoot is hugely important. Okay, I have just a few thoughts left I want to leave you with. These are not quotes by these people. These are things that I have learned and I've taken from interacting with these individuals. So what I learned from Dr. Phillips is one thing he always said to me was always be above reproach. So in anything that you do, you have to behave in such a way that there's not even a question about what you're doing. And he always would say that you should conduct your research in such a way that you would trust all of your data so that you're poised to take advantage of any opportunities that arise as a result. So if you have a weird fluke data point, how much are you going to invest in following up on that versus just throwing it away? But if you do it right the first time, then you'll have a little more faith. But he also would care about the person and not just the scientist. Every time I saw him, from the time I graduated until now, until he passed away, the first thing that he would ask me is, how's the F1? Referring to my kids. I don't know what that says about me, but yes, he always referred to my kids as the F1, and he always wanted to, that was the first question he had. He wanted to hear about how my kids were doing. And I thought that was just, it was sweet. And I did get the chance to talk to him and tell him how much he had meant to me, and I listed these things, in fact. And I remember we were at a conference at the time, and his wife, Judy, was there, and she kind of walked in right as I was finishing up talking, and he looked up and he said, Addie's given me her testimony here. This is very sweet. Dr. Norman Borlaug, I already said some of this, but he really focused on training and education in youth, and I think that's hugely important. I've tried to do that as well. We do a lot of outreach in the lab and work with students of all ages, as well as teachers and politicians and anyone that's coming to the university. And that soft skills are essential and they can come from experiences outside of your formal training. He would often make parallels between his work in wrestling and his work as a plant scientist and some of the skill sets that people needed to learn from participating in something like an organized sport. The things that I would add is that the networking that you're doing now is really important. It's important to have some fun, to build a community of peers and mentors, and then also to, as I mentioned, work on combating imposter syndrome in yourself and others. Okay, funding acknowledgements real quick, and then I'm happy to take questions if there's any time. Thank you, everyone. His name is Link. He really, really likes eating sweet corn for whatever reason. His name is Link because my husband's childhood cat was named Zelda. So the kids wanted to name him Zelda, but he was a boy, so he's Link.
I was gonna ask, so in your talks, or sorry, it was the next response trial, you compared hybrids and inbreds, to kind of get a feel for genetic differences, I'm assuming, in the next response. Why did you think hybrids and inbreds?
So all of our initial work was only in hybrids, and it was in a small number of hybrids, about 16, and we were classifying different response types and learning about the physiology of the response. Keep an eye on plant physiology. There's a paper coming out any day now that talks about a lot of that research. But so this was funded through a collaboration with industry, and their real question was that they wanted to eventually create these like markers that would predict how well a variety was going to respond. And they were convinced that we could do this with this number of 5 or 6 hybrids or whatever. And I hated to break it to them, but I said, I mean, you can get a good list of candidates, but there's no way we can narrow that down unless we have a really broad pool to draw from. So the reason that we have hybrids and inbreds is because I wanted to have some of the power to be able to do things like genome-wide association studies. And that will give us that power, I think, I hope, especially using some of the drone-based data. I didn't show any of the results of some of the data analysis that we've done, but we're able to really sort of tease apart different response types, I think, from some of the data over time. So I'm optimistic. I don't know how well the endpoint will be, but I think there'll be a lot of interesting, cool science that comes out of it. Part of it also has been communications with collaborators in other areas. So, for example, we attend the Maze meetings every year, and that was in part thanks to Gary, who took me there the first time many years ago. But I asked around to the people who work with nitrogen studies a lot, and I said, well, do we know what is like the heterosis for nitrogen response? And the answer was, I don't know. No one really looked at that before. And so I said, well, I guess we got to grow some inbreds and some hybrids and look at how that works. So yeah, I could talk longer, but I'll leave it there. Any other quick questions? Otherwise, you can catch me at the reception. Thank you.
Wonderful. Thank you again, Addie, for speaking to us. I'm now going to introduce our keynote speaker, Dr. Govindaraj. He received the Borlaug Field Award in 2022 from the World Food Prize, and we have the honor to have invited him. Dr. Govindaraj is a senior scientist at the Alliance of Biodiversity International and CIAT. He manages the Biofortification Crop Development Research Network and builds research capacities for biofortification mainstreaming, among other tasks in the Harvest Plus program of the CGIAR. He holds a PhD in plant breeding and genetics from Tamil Nadu Agricultural University in India. His efforts and more than 12 years of experience in crop improvement have been instrumental in the public-private partnership on millet and biofortification. Previously, he led the millet biofortification program in India, West Africa, and Central Africa, and at ICRISAT. Later, he coordinated the Asia sorghum breeding program. He developed and disseminated 12 biofortified cultivars in India and Africa. He has supervised the dissertation and several master's and PhD scholars. He is also the author of over 100 peer-reviewed publications. His research impact is estimated to be 10 million people will be consuming biofortified millet. He's also a fellow and member of many societies. And with that, let me I invite up Dr. Govindaraj.
Thank you. Good afternoon. Thank you for the opportunity to speak about our work. And morning I met the organizing committee, and they told that, in fact, I'm less aware that Borlaug had all the 3 degrees from this university. So I was not met any time, in Borlaug lifetime. So, but this opportunity gave me a support of, Minnesota family at this university. Thanks for this opportunity. I will not give much of technical detail to provide the what's really I want to communicate to the student, the basic of the biofortifications. So the work which I have done with the partnership with the National Research Agriculture System and CGIAR is the biofortified millets and as well as the sorghum. So these two crops are very important in Asia, especially in India and sub-Saharan Africa. So biofortification, as many graduate students are aware, here the definition is slowly evolved and is most mature, I would say. The biofortification is nothing but enhancing the bioavailable micronutrient in edible parts of the staple food crops, which can have the measurable health impact after regular consumption. So therefore, biofortification and fortification is almost targeting the same goal. As I mentioned, that Harvest Plus is one of the CGR challenge program. Is this year 20th anniversary celebrating Harvest Plus the family, and this is coordinated earlier by Alliance Biodiversity, CIAT, and as well as IFRI. So now the one CGR mapping is slowly moved to the entirely International Food Policy Research Institute. So as I mentioned that biofortified and fortified is goal is the same, but the biofortified is for most of the long run. For the short term, the biofortification is work for the countries which have the capacity of the investment and monitoring of these any quality measures to deliver the fortified foods. Whereas the rural people who consume the growing food crops, the biofortification one which can support their nutrition. So why all we are doing the biofortification is a 20-year investment and partnerships going around the world, including CGIAR as well as the National Agriculture System. We all know that even the recent data from the FAO as well as World Health Organization jointly published that about 3 billion people doesn't have the access to the healthy diet on a daily basis. This is largely prevalence in low and middle income countries. So if you analyze that, so what is the cause is happening around that? The food production is so far not optimized in our opinion, and this is what a deliberation is going on. Our aim is to this food security. It should be part of the food nutrition security should be part of the food security. So every state and country policies, we have the nutrition in the legal documents. But however, when it comes to the research and investment, this is less invested in my opinion, and there are a lot of evidences. Even India, we have the Constitution of India, it has the duty of every state to raise the level of nutrition. Of course, not just through food, but it overall, but if you through food the maximum you can attain. So you can the picture simply explain that how the nutrition is distributed. There are the stable food crops can reach maximum so that you reduce the unreached population by the supplement or other interventions. Therefore, you can reduce the investment in the nutrition interventions. And the other recent literatures and research highly evidenced that the increasing climate change all put together, especially the increased carbon dioxide, is going to increase the micronutrient deficient population. If you see that is almost 1.7 billion people is predicted to be deficient in the next 30 years. So this is kind of alarming. Is a prediction. What she's presented, the prediction also helps us to be prepared well in before, and therefore it's very important to prioritize the trade. How we do prioritization. The prioritization comes to the crops and the regions and the populations. Is a more of dynamics. The word Harvest Plus so far used in the biofortification priority index is the interactive tools. So one can access, which is still available in the internet. So which gives that the data of more than 12 crops in 120 countries, which analyze both production index, consumption index, and micronutrient prevalence index. So all put together, which tells that the investor or the researcher and what crop and which nutrient and which region we can focus. So therefore, it's a very important one index developed, and we can keep on improving that index to improve the prioritizations. So the crops we work, almost 12 crops is the major staple food, but it is categorized according to the nutrient, iron, millet and beans, and zinc, wheat, rice, and maize, and vitamin A, sweet potato, cassava, and maize. So this is the crops so far invested, and the breeding cultivar has been developed with the partnership. So how we do the breeding, is that the target is very important. As one is the priority setting, other one is and what level to be treated and where we are today. The baseline is assessed based on the cultivars grown by the farmers or commercialized by the private sector or the public sector, not the germplasm which is sitting on the cell. So the issue is that is a critical issue. We need to look after the genetic variation, what is really grown in the field. So therefore, the light green one, you can see that it tells that what genetic variation is available in the cultivars. And the green middle one is tell that what is the target level one can achieve as per the definition I mentioned, at least 30% of RDA for the given nutrient to meet through the regular consumption as per their crop per capita consumption. And the dark one is so far invested with the partnership and the great efforts by the crop community that was achieved. So therefore, it is very important to have the baseline and the breeding target. It's not always elevated also to measure the progress. So therefore, it is very important to have that type of metrics. So what changed? And during some of my meeting with other people, they asked what changed. This is really a boost for the biofortification program, the prediction technology, estimation, the micronutrients. So far we used AAS and ICP, and now is MS technology. But this XRF, X-ray fluorescent spectrometry, is used largely in the mining industries, which is also in the steel industry. But Harvest Plus and Flinders University, Australia, and the Oxford Instrument have worked closely and a couple of years, and they found that this can be used there for the plant sample, and it is non-destructive, and it is very easy. One day you can do 300 sample. If you are working more than 8 hours, you can do more than that. So therefore, the Harvest Plus program invested more than 25 plus XR placed all over the world, and largely the CGR Center, as well as the National Research Center. And these are all the crops we have the method established, and for zinc, iron, and provitamin A. But XRF, as far as XRF is concerned, is only iron and zinc, not the provitamin A. We can't detect. We have to use NARS. And then the selected sample, the top 10% of the final stage gate, final product to be sent for ICP for the confirming. Otherwise, the breeding people has to invest a lot of money in the screening the sample, then it will be more reluctant to breed for that trait. The genetic variation, I will just show the example of pearl millet in this case. So what I mentioned earlier, what's the pipeline cultivars, the commercial cultivars, which has grown by the farmers, are really don't have the adequate micronutrient, which supposed to the crop has its own genetic variation. So this tells that is mainstreaming in bread and commercial hybrid and germplasm and biofortified lines. So this is clearly indicate that how these farmers grown varieties have been fixed. It's the percentage of the micronutrient class, how much percentage it is achieved. This is the target level. So it is qualified, very few, or in fact almost 98% is almost 100% is less than the target. Of course, that was a prediction. But if it comes to the germplasm, germplasm has a good variations, but that has to be developed for the yield and productivity traits. But comes to the biofortified lines, which is a combination of the productivity traits as well as the nutrition traits, which is focused that trait. With really almost 98% is achieved at the target level. So this indicates that a real focused breeding can bring together the trait together. A sorghum and other millet variability also assessed for a various trait, but we cannot do the prioritization again because each crop is a specific advantage as it's for micronutrient or vitamin. Say for example, finger millet is already high in calcium. Identifying those variety and promoting that's good is enough rather than investing in the breeding program. This is how the simple flowchart I made just to indicate how the breeding program quickly deliver the product without much time taking. This is the one approach we followed in the pearl millet. The pearl millet is highly cross-pollinated like corn, and it has its own breeding pool. Is a female or male? Female is called seed parent, male is arrestor. And this pool has analyzed for the given target traits, and those selected lines were crossed to each other and then made inbred breeding again. So within the gene pool and then crossed between for the fast tracking and the hybrid testing. It was worked for few hybrids we found because you cannot expect more than that. However, the intra-population improvement as open pollinated crop variety is also important when you are trying new traits. One can easily explode. This is also possible through single plant selection. So this is how we did, and it almost testing in most of the countries. And so this is a couple of years back data. Some of them were released by now. It's not possible by one program or the one scientist or one center. It is all possible because of the partnership, and it's well-aligned mission-oriented program. This is for State Agriculture University in India, and also State Seed Corporation who directly work with the farming and seed producers. So therefore, we need to get them involved in scaling up before you get the pipeline released. That is very important when you are doing novel variety hybrids. It has to be done in parallel. So this private sector is not exceptional. So we are very much inclusive, and there are almost 16 companies were part of our consortium. And that map you see almost all over part of the millet growing regions were captured in our GYE testing with this partnership. So finally, these are the first wave of pearl millet biofortified hybrids, which qualify as per the varietal release nomenclature, yield, disease resistant, etc., and plus the micronutrient. The one open pollinated varieties we released in Niger, and almost this year, 2023, also released for Nigeria. So almost mentioned in the ECOWAS bulletin, which is qualified for as a seed mobilization across the 15 countries of Africa. So when we introduce this variety, there is a perception only very long panicle, long head is mostly accepted by the African farmers. But when we visited and inquiring, so they are worried about a particular season where they don't have the millet to eat as a food. So especially it is early maturing variety they're targeting. So we took that opportunity. So this is the open pollinated variety, which matures almost 20-25 days early than the normally grown varieties. So then you added the advantage of the micronutrient. So what I mean to say, micronutrient alone cannot sell into the farmers community, or they always want the farmer preferred traits, either maturity or productivity, disease resistant. So therefore, very key to mobilize this type of work with these farmers, and acceptability is very great. And the long panicle, why they said is they have to tie to carry to the field, from the field to the home or the market, and they will thresh before 1 week or 2 weeks before consumption. But we've also followed that is you put the panicle in a reverse order, vice versa. And you can tie even the smaller types. So this was demonstrated. Farmers were happy. It's not a big innovation, you know. So this all is we need to convince them how is possible. As the interest of the student, graduate student, you should know the trait genetic as well. As a breeders, before developing, we have done n number of studies with the various students, and these micronutrients, you know, is a quantitative traits. So therefore, there is a quantitative genetic variation exists, and it's largely additive genetic variations in most of the, not only pearl millet, in most of the crop for this trait. So therefore, the breeding value is higher than the productivity traits, I would say. Since highly heritable, it is easy to select, you know, also from parent to upstream. And the stability of the trait is much better, I would say, than yield, because the G by E interactions is play in micronutrient estimation as well. But when compared to the yield, it's much lower. So when we're dealing with the yield and coupled with nutrition, I think it's easy to select together. The highly association between iron and zinc in most of the crops is positive and highly significant. But when it comes to the yield, it's not always negatively significant. So there are chances, so one has to use a large breeding population to select when you're bringing the new traits. So genetic variation is available for in the allied population. The major QTL are being detected for this micronutrient, especially iron and zinc in case of pearl millet. And now the program is started using SNP markers. In later slide, I will show some of them. And most of the publication is available in the Google Scholar. If anyone interested, please look at this. So this is part of the breeding progress, how the seed parent, the B by B program or the restorer parent, how is improved is we always use the check like any other disease resistant check. This is a high iron check for the female, and this is the high iron check for the male. How the mean is moved gradually from one population to the other population. When you advance, this is highly possible because if it is additively controlled and your selection is highly heritable. And also we do the disease resistance. So I asked my colleagues, you know, Rajan Sharma, to share some of the slides, but fortunately he shared that work which we did is the biofructified lines. You can see the downy mildew is one of the major concern in pearl millet production, not only in India as well as also in Africa. This is always we used to screen these various type of, you know, isolate. So he's named here. All the isolates is collected from different region. It's all control conditions. Screening, if you see, is a good number of lines. I don't want to go to details. The good number of lines as, you know, you were classified as a tolerant. As she mentions, tolerance is the most appropriate word. So this is some of the line we identified. For DM, similarly, there is a blast, you know, really blasting the millet production in recent year. Especially in India, because the high humidity in the rainy season, this is the rainfed crop. So this is one of the greenhouse screening and also the field study, which is after selection, which indicates that, you know, at least a good number of lines, which shows the green one, the resistant. And of course, we also work with the moderately resistant because we need to further select. These are all the breeding pipelines. A genomic progress, yes, for the diseases concerned is very much needed because it's very dynamic in nature. So to avoid G by interaction, this is genomic is largely used. And even a couple of the hybrid in India released using the marker-assisted selection, the QTL introgression. And this is the Meha variety in India, which occupy almost 40% of the area. So this is improved by male parent, improved by the disease resistant. And similarly for the blast, they are working, and one hybrid HHB146 is being improved for the blast disease. And the SNP marker, as I mentioned, for iron and zinc, And this has 10 markers. Out of 10, 6 were, in the last 6 were the drought related traits. The first 4 is related to iron and zinc. So then comes to the food system, biofortification cannot stop at the breeding, but how we can integrate it to the food system, scaling our industry need to scale, how to do that. Everywhere seed has a class and it has its own authority. So as flour and processing industry has, but how to connect the grain which is farmer produced, which is highly qualified, in association with the Global Alliance Nutrition Gains and BSI British Standard Institution and Harvest Plus work together and established for all these 3 micronutrient specification, which is publicly available standards. So this helps the scaling partner or industry one can procure at the different grade. Whether it is 5 fortified or not, this is indicated for here for iron. I am sorry, the font size will be smaller, but this presentation is available here, or it is also available in the open access. One can explore this. Class 1, class 2, class 3. The class 1 is the maximum, the target achievement, and the last one is the 30% and 50% achievement of your target. So this is very important, and based on that, and slowly Indian Council of Agriculture Research, which delegates and controls a major agriculture crop development in India and releases, and they come up with the nutritional status and their trait availability in the released cultivars, and they're publishing, and we are working with them for the national crop standards. Yeah, as at the end of the day, it's must to have how long we can do the specific breeding program. We have to mainstream at one point of time when the capacity is ready, material is available, and trained people, as she mentioned, the trained expert is available. So therefore, mainstreaming is important. We see that 42 or 47 ppm in the global. This is the baseline. When the biofortified reached almost close to 80 milligram per kg, we need to mainstream bridge the gap. So we need to move the black one to the blue. So therefore, the ultimate goal is done. How it is done, the mainstreaming investment is very key. That's what we are making the strategy with one CGR as well as the National Agriculture Program. Those crops which is heavily invested in the last 20 years to make significant progress in the genetics and the material generation, that has to be do this mainstreaming part very clearly. Slowly, the capacity building is our earlier year is very much important, and slowly the targeted biofortification should be disappeared. The opportunity and value chain the Harvest Plus took is advantage is any crop research organization, the breed, the develop, okay, maybe to the certain extent to partner the release. Okay, what happens next? We don't have any connection, but Harvest Plus took advantage having the diverse partnership, starting from the crop research, the trait discovery and crop development and release. It's not stopped there. It's slowly building the seed multiplication, working with the license or the public sector and the seed distributor, and the farmers and grain producer, as I mentioned, the publicly available standards are generated to link them. And slowly, now we're starting the food manufacturer, how to connect with them to processing, and then finally retail consumer through the startup and entrepreneurship. So therefore, it is very important to connect this. Unless we do that, we will break our innovation in the middle. So therefore, it is very important, as I mentioned, nutrition should be valued during the crop improvement. The impact, if you ask me what impact is made, is a good number of farming families grow this one. This is last year, 2022 data, almost 366,000 as household is growing. But there are number of independent clinical registered studies conducted using our own varieties. And it comes with a finding that consumption of the iron millet 4 to 6 months is reverse their iron deficiency, especially in children and adolescent girls. So therefore, it is very important to look at that perception scale and to improve the dissemination for the needy people. Therefore, it really makes sense when we do mainstreaming in the biofortification. These are total crops released and other crops as well. So this is also one of the constraints, It's not number of varieties we released so far. It's not going to make a big impact. However, how much produced, how much reached the farmers and continue in the farming cultivation is determined by the seed production and dissemination. This is one example from the ICAR released in 2022. These many crops biofortified. And the seed production you can see is not up to the mark. This is a challenge we're discussing. We need to improve the public system involvement in seed production and reaching the farmers with the biofortified. So as I mentioned, Harvest Plus celebrated 20 years and it reached several millions and rapidly we are closing to 100 million by 2023. Our target is 1 billion people by 2030. It's not by ourselves, it is all need to the institution like you, collaborations, everything, dissemination. It happens, we expect to happen with the funding as well. So the key message is that biofortification is not an exceptional. It can be doable since this is a quantitative traits, just like Borlaug did is a dwarfing gene introgression to reduce the height of the weed is one way, make the revolution. This is also like a D2 gene, which it cannot genetically deteriorate itself. Micronutrients highly heritable. So therefore, the crop variety which comes in the future, which is recommended, is one of the core traits. And policy advocacy, creating awareness, as I mentioned, Harvest Plus developed standards can work as a model, but can be built more systematic using the prediction and other available phenotyping data in the region and the given crop. A very important is the involvement and investment of the national agriculture system who really deal with the regional farmers and producers. Very important. On top of it, involvement of the private sector is a key where we are moving more of entrepreneurship and the private sector involvement in commercialization. The changing climate is expected, is just predicted. This will change the disturb not only calories, but also the nutrition supply. Therefore, millet is also one of the important crops can be positioned, in the food interventions for nutrition costs. So other needed advanced modeling, as the previous presenter Jackson mentioned, she mentioned that this is very predictive in corn, but this also should be replicated in other alternative crops like millets and other. It need to improve the productivity as well as the resilient traits. The complete transition is needed. As I said, targeted breeding 20 years has been done. We cannot continue as a separate, a special price for some time in the market. That's not our ultimate goal. It's our ultimate goal is to when farmers get the variety which has come from the mainstreaming that have the adequate nutrition plus other traits. So therefore, it's very essential. So with that, once again, I thank the organizer and thanks for you for listening. Yeah.
Thank you, Dr. Govindaraj, for that wonderful presentation. We have about 5 minutes scheduled for Q&A. If anyone has questions for Dr. Govindaraj.
With that, you can't see it. Send out only variety. It gets across in the local varieties. Your way to have considering linking this with physical markers. Thank you. Good listening. When we adding the iron, I think we will be also the concern for acceptability, we should achieve the color, taste, therefore we are not much focus for the visual markers, or except orange, maize or orange, cassava, which then distinguished now, therefore we have the other quality proteins. The real ones I think is markers. It comes to be a combination with local qualitative. Largely, this is the senior effect, I would say, and steady it's on the cross. It's like there is no senior effect, which is for the comp and the other field, which materialize on the sea, whatever the nutrition levels are experienced. I would say part of the village, the part is very important. The anchor, being the cross-pollinated crop, we don't have the basic change. It is probably processing. But this is very important angle we should follow the future. The people keep the evidence. The visual monitor, I'm sure that maybe the lines become
Thank you very much for dedicating your time and life to this important solution. You emphasized a number of times the importance of connecting with breeding to the retail, to the actual consumer. So I'm curious if you have any data on variety adoption and replacement in the communities that grow it. And also if you could talk a little bit about what they're doing, if they're doing bonus payment or higher nutrition, how they're supporting growers to varieties.
But in first thing is an option. Yeah, we do have the data. Most of the crop they have this but in fact, the country like India, they made a policy that any variety which more than 10 years. So it's growing and slowly they even high. So then when we introduce a new variety, we is targeting the one variety. So we have, say for example, Shakti, which I showed, they trace the existing they open variety. Right? It completely is replaced 100%, I say. Rather than completing the hybrid program, but less training is probably best name. Only in Africa before, that's why hybrids. So India, the hybrid combination. So hybrid is specific to the East zone. We have a zone in India. Those zones is slowly distinct. But it takes, as I mentioned, seed production in one issue to keep and release the harmony. That's the part the complete. So therefore, we do have the data, but not to that degree 100% this year. So it takes time.
How do we incentivize growing?
So that's the many forum and many people ask us, and in fact, myself asked the other management. But how we can promote the growers or buyers. But the collective deliberation on that is that the ultimate goal is to ensure the breeding program to improve these trends. But in short term, yes, some of the country, the policy has been devised and is already implemented in order to African countries which promote the education with subsidies, etc. But in the long term, this is not going to give special price and premium. One has to invest, one thing is that it should not end in shares happening that you invest. And it's targeted by which is mainly targeted at the rural environment farmers to grow and consumers. So therefore, very, very large to have the same variety itself.
So another thing is the mainstream, that's what I just suggested, right? Top now is 10%, 20%. It takes 10 years, a decade to mainstream completely your pipeline. Once your pipeline mentions, but to couple of years or a short time to continue to promote and to make awareness, the incentive is already being discussed in the policy maker. So that's the only thing. So the buyers also premium price, don't subsidize.
Any other questions? Thank you, Dr. Govindaraj, and do have again as a thank you for speaking today.
Thank you.
And I'm gonna hand it over to.
Dr. Govindaraj, Dr. Johnson, thank you so much for being here with us today. Your work and your insights have been truly inspiring. This lecture has been a wonderful tribute to Dr. Annual Borlaug's enduring legacy. We extend our heartfelt gratitude to everyone who made today's lecture possible, and to those of you in our attentive audience, thank you for your presence. But the event is not over quite yet. We invite you to a reception in the Borlaug Commons right around the corner for refreshments, for snacks, and of course, vibrant discussion. It's a perfect opportunity to connect, to exchange ideas, and be part of the ongoing mission to uphold Dr. Borlaug's legacy. Let's keep the conversation going and the flame of inspiration burning brighter for a more nutritious, more food secure future.